Today we are graphing the other trigonometric functions. Those will be tangents, cotangent, cosecant, and secant. So we're graphing the other four remaining ones. We're going to start off with the properties of the types, and we're going to graph a few examples of each. So, if you recall from your problem of the day a while ago, we actually graphed tangent the same day that we graphed sine and cosine in our Pi notebooks. Okay? And so, looking at this graph here that we have of tangent, we can figure out some of these specific type of properties. So, domain. Is it all real numbers like sine and cosine were? No, why not?
They are asymptotes.
They're asymptotes, so there's points of discontinuity. So we need to incorporate that in our domain. So
Yes, pi n plus pi over 2n.
Is it every pi over 2n?
Yes. Why? No.
This is the one where you said
No,
it
because
was plus pi over 2 and then every pi. Right? I don't remember how you wrote that.
How do you write that?
Pi over 2n plus pi.
Pi n plus pi over 2.
Pi n plus pi over 2. So it is all real numbers except not every pi over 2, because think about it. If this is pi over 2, this would technically be 2 pi over 2. So that won't work.
Oh, so it's plus pi over 2 pi.
Is that every pi n plus pi over 2. So I'm going to write that in set notation because there's really no way I can write that in interval. Okay? So that's x such that x cannot equal pi over 2 plus n pi.
That's exactly what
X is an element of what do you think? Huh? All real numbers, but n has to be what?
like natural.
An integer. Because it does apply to your negative numbers as well, doesn't it? Your negative pi over 2 and your negative 3 pi over 2. What will your range be?
Negative infinity to infinity.
Negative infinity to infinity. X-intercepts.
It's the same.
It's every multiple of pi, so how do you represent that?
Pi n.
Pi n, where n is
Integer.
an integer. And my y-intercept is 0. Is it continuous?
No.
What type of discontinuity does it have? Infinite. And where do they occur?
Pi over 2 plus n pi.
Good. I have asymptotes at the same places, right?
Yeah.
I'm going to write that twice. Actually, I'm not, because my pen is too thick, so I'm just going to do it. What type of symmetry does tangent have? Very good. And if it's odd symmetry, that means it is what type of a function?
Origin symmetry.
Extrema means what?
Maxes.
Maxes and mins. Do I have any maxes or mins?
No.
No?
Negative pi. I mean negative infinity.
That's where the discontinuity is. So remember, you usually say continuous when you know infinity, but it's not continuous there. What you guys say for extrema? None. What about our end behavior?
There's none.
Why?
Because there's so many asymptotes. There's so many asymptotes that it doesn't.
And no matter what, you're still gonna.
Yeah. We talked about this.
We never
the exact same thing as absolute. And what is the period of tangent? Pi. We talked about that when we first originally graphed it. And these are your features of tangents. Now do realize that tangent too can go under all different types of transformations, just like sine and cosine can, okay? So we've been practicing with sine and cosine, so hopefully it won't be too challenging to do tangents, okay? We're going to locate where the vertical asymptotes are and sketch the graph 2 periods of tangent 2x. Now this 2x is inside with the x, so technically 2 would represent what variable? The b, okay? So that same setup applies to tangent as well. Okay, so that same setup applies to tangent. So 2 is the b. And whenever we have a b, we always do what to which variable? Multiply your x's by the reciprocal. So I'm going to take all of my x's and my tangent function and multiply them by my reciprocal, which is 1/2. And I'm only going to graph 2 periods of this. The drawings out, so I need a little bit of a reference here. Now the question, if I'm multiplying all my x's by 1/2, does that affect my asymptotes as well? Yes, it does. So my asymptotes for tangent normally occur at every odd pi over 2, so pi over 2, 3 pi over 2, negative pi over 2. Even those get multiplied by 1/2.
Every 1/4.
So it's going to be every 1/4.
Every 5 over 4. Every like.
Every what? How can I represent that? You're right. It is going to be pi over 4 now.
So
But it's going to happen at every pi over.
No, like pi and pi and plus pi.
Okay. So every pi after pi over 4, is that what you're trying to say? Okay. So my next asymptote was at 3 pi over 2. Right? So if I multiply that by 1/2, does that take me at that next one over that Ian was talking about? At 3 pi over 4? Is that that one that was at negative pi over 2 is not going to be where? All right, and so there I have 2 periods right there in between those two, or these, between these two asymptotes. That one that was at 0, that's going to get multiplied by 1/2, but it's going to stay right there at 0. And I didn't get flipped over any axes, did I? Yes, no? No, so I'm still going to curve up this way, curve down this way. And that point that was at pi 0, is now going to be at pi over 2, 0. Okay? So all those y values, all those x values are going to get multiplied by 1/2. So that's 0, pi over 4, pi over 2, 3 pi over 4, and pi. My y's, 0, undefined, 0, undefined. Questions? Because remember, on the original graph of tangent, there was an asymptote with pi over 2. So now that asymptote occurs with pi over 4. Same thing with 3 pi over 2, now it occurs with 3 pi over 4.
So there's what is the circle?
0. So those are still x-intercepts. Because nothing happens to my box. Questions? asymptotes. Yes?
So that 2 in the original function y equals tan 2x, that pretty much just shrinked it.
Mm-hmm. Because you remember from transformations, anytime there was something attached to the x, it was a horizontal shrink or stretch by the reciprocal of that number. So if it's a big number, it gets squished inside. Yes?
So if it was like 1 over, if it was 1/2,
It'll get longer. Looking at this one. What's going to happen? It's going to be wider. So that means all of my x's are going to get multiplied by what number? 4. Okay? So, if all of these x's are getting multiplied by 4, nothing's happening to my y's, right? Those all stay the same?
Yes.
Okay? So, no longer am I going to be, well, am I still going to be a 0, 0? Yes, I am, because when I multiply 0 by 4, I still get 0. So, I still have a point there. But I'm no longer going to have an asymptote with pi over 2.
2 pi.
It's going to be at 2 pi. Because I have to multiply all of my x's by 4. So it's getting stretched out. Everything moves. Everything
The
changes.
smaller the number is after the tangent, the less asymptotes you're going to have.
No, you're still going to have the same number of asymptotes. It's just they're going to be more spread out. Because basically the entire graph is getting horizontally stretched by a
I
factor
mean,
of
like if
4.
it's telling you to do a period, like graph 2 periods, you're going to have less asymptotes than if.
Between 0 and 2 pi, yes.
So,
I don't mean like to infinity yet, just like this.
so only the ones, okay, so based off the, like, what would be appropriate for students is a parent function?
That's exactly what it is.
At like, only the pi over 2, 3 pi over 2 are the asymptotes. So we know that for all tangent functions.
Yes. Just like we know that 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi 0 are the points for sine.
So, by multiplying the ones that are the zeros by 4, they don't, the outcome doesn't matter for your asymptote wise. Only the ones that you have already identified as asymptotes,
Exactly.
they're the product of that multiplication becomes a new asymptotes.
So where is my next x-intercept going to be?
4 pi.
At 4 pi. Okay? And then my next asymptote after that is going to occur where? At 6 pi. And so if I went out that way, that would be the end of my 2 periods. Okay? Because you'll have one, like this. Where's my other asymptote in the negative section?
Negative 2 pi.
Negative 2 pi, but after I multiply it by 4, it becomes,
Wait, what?
-2 pi.
No, it's negative 2 pi.
it's going to be over here at negative 2 pi. And that is 2 complete periods. Questions?
So what is the ones that are the zero, the 4 pi, the zeros are just
X-intercepts.
x-intercepts and that?
Questions?
That's 4 pi.
I want you to try the next two on your own. So, this negative means what? It got reflected over which axis? It got flipped over the x-axis because your y's became negative. There is no b, there's a 1 here, but it doesn't change my period. It's not getting longer or skinnier. It's going to stay where it is. The only difference is that this pi over 2 means that my graph is doing what?
Moving to the left.
Oh, I just thought about that.
Moving to the left, pi over 2 units. Think about it. It's in the C spot. C over B, negative C over B gives me my phase shift. This is a phase shift. So no longer am I going to have an asymptote at negative pi over 2. It's going to now be at negative pi. And no longer am I going to have an asymptote at pi over 2. It's now going to be at 0. And no longer am I going to have an asymptote at 3 pi over 2. It's now going to be at pi, and so on and so forth. Where are my x-intercepts going to be now? Negative pi over 2. Pi over 2. 3 pi over 2. So all of your pi over 2 plus n pi's. So everything, asymptotes included, they all get shifted over whenever you have a phase shift. This is what your graph should. That's so wrong. Forgot to flip it. Sorry.
So it's like that.
Because it gets flipped over your x-axis. Okay? Do the next one. Give you about 30 minutes. So in this problem, hopefully you multiplied your x's by negative 1/3 because there was this negative 3 attached to your b. And there was a phase shift. Remember, it's negative c over the absolute value of b. So you should have subtracted a pi over 3 from all of your x values. So if you multiplied all of your x's by negative 1/3 and then subtracted pi over 3, you would have gotten negative pi over 3 for the first one.
Wait, what? Are you would add pi?
This is in the same spot as all of those other c's are with your sine and cosine functions, okay? This setup. dx plus c. Okay, and so to incorporate that c, you have to do negative c over b to figure out exactly what that phase shift is. The reason why we didn't have to do it for the other one was because b was 1. And c over 1 is just what it was.
Okay, so this would be c over.
C negative pi over the absolute value of b, pi over 3. This one, when you multiply by negative 1/3, it's a negative pi over 6 minus pi over 3 is I believe somebody help me. Let me check. Thank you. Yes, ma'am.
Okay.
Wait, so you do
pi over 2
common denominator.
times negative 1/3, that's a negative pi over 6, right?
Yes, ma'am.
And you have to subtract that by pi over 3. Common denominator would be 2 pi over 6, right? So then you have a negative pi minus 2 pi, which is negative 3 pi over 6.
So what was the on c negative pi over absolute value of p?
To find the phase shift is negative c over the absolute value of b. Pi.
Okay.
Why?
Why? Why?
So I think what I did was I subtracted by pi, so then I got a common denominator of 6, and then I just subtracted and I got negative 7 pi over 6.
That's what I'm starting to notice, that a lot of you guys are forgetting that when there's a c there, You're not just adding, subtracting whatever C is, you have to add or subtract whatever your phase shift is, which is a combination of negative C over B. The other problem, B was 1. So when we did negative C over B, it just ended up being whatever C was. So that's why we just added or subtracted just that one number. And so, can you guys help me out with some common denominators and some adding stuff so I can get the rest of these points so I can move forward to cotangent? Okay, so what is pi times negative 1/3? Negative power 3. When I subtract the negative power 3, thank you. All right. What is 3 pi over 2 times a negative 1/3? Negative power 2 is negative power 2 minus pi over 3. And what's 2 pi times negative 1/3? And then minus a pi over 3 is a negative pi over 3 is negative pi. So these are my new points. Why am I over here in my negatives? Why am I over here in my negatives? Because the B was negative, and if B is negative, that means I'm making all of my x's negative. So it got reflected over the y-axis. That's why all of these are in the negatives. Question?
You made it negative.
How did you get negative pi from 2 pi? I'm so confused on that.
Because 2 pi times a negative 1/3 is a negative 2 pi over 3. Then you subtract it from pi over 3 to get a negative 3 pi over 3.
Gotcha. Thank you.
So I have an asymptote here. Nope, just kidding. I have an x-intercept here. I have an asymptote here. X-intercept here. Asymptote here. X-intercept here. Cotangent is very similar to tangent, okay? Except, or looks similar to tangent. Only difference is that its domain is not, it's undefined at every pi. So our domain is x such that x does not equal pi n, where x is an element of all real numbers and n is an integer. Its range is still negative infinity to infinity. Its x-intercepts change as well, because if you remember from tangent, all your x-intercepts were multiples of pi. This one. It's 2 pi, or pi over 2 plus n pi. You don't have a y-intercept. What's happening on your y-axis? There's an asymptote there. It has infinite discontinuity, just like tangent, but this time it's happening at every pi. Yep. What type of symmetry does cotangent have? There is none. Because if I try to flip it over the y-axis, this curve is a being here.
What about
Because if I were to reflect this over the y-axis, this particular part of my curve will be over here instead. Do I have any extrema? No. What about in behavior? Same as tangent. And cotangent, tangent are all graphed just like sine and cosine are. You guys forgot how to graph trig functions in a few days? That's what it seems like. That's where the issue is. Y'all had a really hard time trying to graph tangent. Okay, the same rules still apply. You multiply your y's by your amplitude and your vertical shift. You multiply your x's by 1 over b, and you add or subtract your phase shift. You had a question?
I'm just trying to imagine what it would be if it flipped over the origin. Like, would it pop up something to do that? Like, every point that I make, it adds up. On the, like, fx, over 2, that would be okay.
He does that. Origin symmetry. It does have origin symmetry. But you're right, that point of power 4, 1, if you put on the origin becomes negative power 4, negative 1, which is that point there. So it is origin symmetry.
What you're saying before, I'm graphing x is your divided by b and plus or minus c.
Multiply by 1 over b, and you add or subtract your phase shift, not your c.
Or y is that?
Multiply by your amplitude, add or subtract your vertical shift.
I've written that down. I think I would have like been better if the because like the video was I watched it and the video was good. And it's like easier to comprehend and like ask more questions.
We're going to graph this one before we move on to secant and cosecant because I need to make sure I get to those. We're graphing cotangent of x over 3. X over 3. Which variable is that? A, B, C, or D?
Which one that's the b.
That's the B. And what value is B? 1/3. So B is 1/3. That means which variable is getting multiplied? The x by multiple or multiplied by what?
3.
3. So that means that all of those x's at pi over 2, pi, 3 pi over 2, and 2 pi all get multiplied by 3, just like before. Just like before. So 0 will still stay 0, but pi over 2 will become
3 pi over
3 pi over 2. Pi will become
2. 3 pi.
3 pi over 2 will become
9 pi over 2.
and 2 pi will become
6 pi.
6 pi. Okay? Just like before. Anything happening to the y values?
No.
No, because there's no a. Well, there, a is 1, but that means nothing. And d, there's no d. Okay? Be cautious. Where are your... Where are your asymptotes on tangent? They're going to be at 3 pi over 2. Sure? Cosine? It'll be on 0.
Wait, so can
And
you
pi.
label the
Mm-hmm. Because if you recall from cotangent, your asymptotes are occurring at 0, pi, 2 pi. So all of those are going to have your asymptotes. So this one's going to have your asymptote, this one here, and this one down here. Whereas pi over 2 or 3 pi over 2 now, and 9 pi over 2 are going to be your x-intercepts. Okay? So I have an asymptote at 0, 3 pi, and my 6 pi, which I couldn't fit on the screen. And I'll have x-intercepts at 9 pi over 2, 3 pi over 2, and I'm cotangent, so with the asymptote being at 6 pi, that's off my graph. Please make sure that you have an asymptote at 6 pi imaginary curve when you draw it on your paper approaches 6 pi. Cosecant was the reciprocal of what? It was the reciprocal of sine, and secant was the reciprocal of cosine. So, the biggest help when it comes to graphing secant and cosecant is you're going to need to be able to graph sine and cosine. Okay? Because what you'll notice is that in the graph of secant, if I were to graph regular sine, secant, you see it? All the maxes and mins are basically where you have maxes and mins on cosecant. And same thing with secant, it's the reciprocal of cosine. So if I were to draw cosine, the same thing there. Exactly. So the zeros of cosine and sine are your asymptotes of secant and cosecant. And then the maxes and mins on sine and cosine are basically the either mins or maxes for secant and cosecant. Okay? So, filling this in real quick. Your domain is all real numbers except an n pi. Okay? Same get up as before. X is an element of all real numbers, n is an integer. Your range is from negative infinity to -1 included, union 1 to infinity. Because if you notice, it's undefined between -1 and 1. Okay, that's where sine would technically be. Your intercepts, do you have any? No, you don't. Do you have a y-intercept? No, you don't. And it's definitely not continuous because there are asymptotes there as well. Your asymptotes occur at every pi. So you have infinite discontinuity. Your pi n pi. So your asymptotes are again at n pi. You have origin symmetry. And you have no view. Question? Uh-huh. Yep. And that's exactly how I'm going to tell you how to graph it. Graph whatever its inverse is, so whether it's sine or cosine, graph that with all the transformations. Then draw in your asymptotes and make your curve. The domain over here is all real numbers except pi over 2 plus n pi with the normal follow after. Your range is the same range as cosecant, from negative infinity to -1 included, and then from 1 to infinity. Just like with cosecant, you have no x-intercepts, but you do have a y-intercept here. And 1, 0, 1. It's discontinuous as infinite discontinuity. And that's at every pi over 2 plus n pi. And its asymptotes are the same. That's its continuity. Those are your vertical asymptotes.
And the other ones were infinite.
Infinite discontinuity. They were all infinite discontinuity. What type of symmetry does secant have? Y-axis is an even function. And it's in behavior. It's none.
So the asymptotes are the same.
Yep. So your biggest help to graph these secant or cosecant functions, you're going to need to know how to graph a sine or cosine function. Okay? So the same rules, transformations, all that as before still applies here. Okay? You just have to make sure that you match the right reciprocal function. C goes with S and S goes with C. Okay? Cosine and cosecant can't go together. Okay? Cosecant and sine go together. Alright?
Oh, that's what I did.
So cosecant is what? It's sine. And what am I doing to this sine function? What am I doing to this the sine function? I'm moving it to the left, pi over 2. Okay? So 1 and negative 1. So what I'm going to do is I'm going to graph sine with a dotted line. Because that's not the graph that I want to focus on. I want to focus on cosecant. So normally sine crosses the x-axis, the y-axis at 0, 0, right? But if I move over to the left, pi over 2, it's now here. This point's now here, and here, and here, and here. All I did was literally take my sine function and move it over pi over 2 units. Y'all remember what sine looked like, right? You haven't forgotten?
In this,
I think y'all might have, yes.
in this one, do we still like have the same equation for phase shift? As we did?
We still have the same equation for phase shift, to graph your period, all that, yep.
So if B wasn't 1, then we wouldn't just move it over to another list.
Right, we would have to stretch it and then move it based off the phase shift. So we perform all the transformations to the original sine function, and then we draw in our asymptotes. Where do our asymptotes occur?
Pi over 2.
And the zeros. So pi over 2 and negative pi over 2,
Wait, that's
and the x-intercepts of your reciprocal function. And then at this point right here, I'm going to have a min, and cosecant is going to pop up. But here, I'm going to have a max, and cosecant is going to go down. I have another asymptote. Where is it going to be? I know that's really crooked, so I'm looking at it from the side, but there you go. And this would represent what I've drawn in red, 1 period. Not 2, just 1. Because remember, periods before the graph starts repeating stuff, so I would need another one of these and another one of these to have 2 periods.
Wait, for it to go, would you need another one up for it to be a full period?
This right here is a full period. If I had another one up and another one down, that'd be 2 periods. Okay? So I could keep drawing this out some more. And then I will have some more asymptotes here, and here, and I will have another max, and another min. I know that's not the best drawing I have, but
We know what you're doing.
so the key thing here with secant and cosecant, you need to make sure that you graph sine with all those transformations, or graph cosine with all the transformations. Drawing your asymptotes, and then actually draw the real secant or cosecant curve based off of where the maxes and the mins are. Okay? Comes with practice. Questions? I'll probably do one secant one before I post the video, and so you'll see a secant one there. Yeah.
So the asymptote, just to make sure the asymptotes are on the x-intercepts on both of them.
On both of them, yes. Yes. For secant, My purple dotted line graph would have been the graph of cosine. But the same types of transformations I would still apply. Others?